Hello everyone, in this tutorial we are going to start to model our Raft foundation using Midas GTSNX, and we will start with 3D model as we can see here. In the 3D model we can go to AutoCAD, and this is the same problem we used for uh, Plaxes, and we will start to, instead of drawing and the software, we can just import it from the AutoCAD. So I'm just gonna go and trim all these edges, and then I take it as edit, copy with base point here, and I put it at 0 and 0, and we save this as DXF. And we say this is Raft, and we say save. We go to Midas GTSNX, and we come here and we say import. This is easy. So now if we have a complicated shape, we can just import it so easily. We go to AutoCAD and we go here, Raft, and I start to import it. We have to import it in the 3D. As we can see here, and apply. Okay, and this is our shape now. All we have to do is start to create face. So we're gonna go to create the face, and we select the edges here and we say create face. And for the Raft here, we can just create another face, 3D, make face. And now if we went here to geometry, I don't need any of these. So this will be my model. Now all I have to do is to go and imprint. And now we can see I can go to extrude my, before I do imprint. Now I can go to extrude 60 meter minus 60, and I will extrude in this direction, and we say apply and cancel. Here we can add like a plate element as we did before, like a 2D element, or we can just create another piece of soil. It's much easier to create this here by just we can start to choose this one, and we go to extrude, and we're gonna extrude it for 1 meter, and I'm gonna select the direction and I select the target, and I start to check here and I say apply. Now all I have to do is to go to Boolean, solids, and embedded, and this embedded here, and I say apply. Now I don't need this face anymore. I don't need this face anymore. If I start to hide this one, I can see easily here my problem. I show everything, and I go now to save my model, and I say save. Now it's easy to go here before this we do something called auto connect and boolean, and we select everything and we say apply. Then we have to go to mesh and we say material isotropic and we say concrete or raft. Here we will start to compare here 2.1 E7, and for the Poisson ratio 0.2, and for the porous plate we're gonna make it 24, and that's gonna be fine. Then we can start more column as we did in plexes, and this will be 60, and Poisson ratio will be 0.3, and unit weight will be 18, and the saturated one will be 19. For the nonlinear parameter we can't edit 0 because of numerical problem, as we talked about this before in other tutorials. So I'm gonna say apply and we call this send, and we say close, and we go to property, and I create a 3D element, we call it soil, and we say soil, and we say raft, and we call it raft, and we say close. Now we already created our problem. Now it's so easily to create a mesh from 3D mesh. I create this hybrid and I call it soil, and we call it soil. I prefer to mesh my raft first, and I will mesh it to 0.25. We can mesh it to 0.5. It's totally fine, and we call it raft, and we say apply. As we can see here, our mesh is a quadrahedral mesh, and for the soil we're gonna check to be 5 meters hybrid, and the property will be soil, and we say apply. It will take a moment, as we can see here, because of the big section of the soil. We can decrease this because we can't create a big difference between the element. So I'm gonna say show all, and I make it 2 meters here, and we say soil, and we create soil, and we say okay. We're just increasing the number of the element. It will take some moment to create our mesh, as we can see here. So this is our section here, and we can show by property color, as we can see here. We can also add a gauging shell here over the raft, so we can create or we can measure the moment. So we can do this from create to the element. Sorry, we can do this. So we just first have to go to properties, and we come to the element, and we create a gauging shell. We call it gauging shell, and we say okay and close. Then we go here to create an other, and from other we choose gauging shell. We choose our problem, select surface, which we'll use. We select the solid to take the stiffness or the thickness, so we can create the stiffness, and we calculate and we show the moment at the surface, and we say apply. At the mesh part here we can see this is the raft, this is the soil, and this is the gauging shell. Now we already finished our problem. We go here to static, we create gravity loads, and we say apply. We create boundary condition. It's much easier in Plaxis to create the model, but it's more efficient here because we can do whatever we want with our model. And we created our boundary condition. Then we go here to analysis, we go to stage set, and we add a stress stage. And for the first or the initial stage, we have to clear the displacement, and we add the soil, we add the gravity load, we add the boundary condition, and we say save. Then for the raft case, we add the raft case. There is something here we missed, or it was wrong, that we created the raft here as individual. But what we should do, to be fair, is at the beginning it's soil as the initial stage, and then we change the property of the raft. So in order to do this, we will learn another technique. So we go to parameter here and 3D, and we select our raft, and we change the property to soil, and we will create another boundary condition called change boundary condition, and we will go to the raft and we change the boundary condition to raft, and we call the boundary condition as raft, and we say apply. Then we go back here to stage set. For the initial stage, we add the soil, we add the raft, and we say save. Then in the next stage, we call it structure. And in this case, we start to add the gauging shell, and we start to add the boundary condition, which make it raft, and we say save and close. We can start to add our uniform load from here, and we go to pressure, and we select face here, and we can just show all the geometry again, and we select this face, and we put, since it's a pressure, so the positive value, it refers to pressure, to compression, so we add 180, and we call it live fluid, and we say apply, and we say cancel. Then we go back to the create the last stage here, and we say new, and call it load. And in this stage, we add the load, and we say save and close. And finally, the last step is to create analysis. And the analysis here is construction stage. And we will use initial. We don't have to consider water pressure. We don't have water anyway. And for the initial stage for analysis, we will choose initial stage. We will solve using a K-node condition. And we say okay, and we call this run A, and we say okay, and we start to run our problem. Our model will take a moment. I will pause the video until the model is done. But as we can see here, it's pretty fast, and because our model is static and we have no problem. We can see that our model is done, and the number of seconds is 24 seconds for this step, and we don't have any warnings, which means that our model is perfectly correct and we have no problem. Now we can go to the panel of the results, and we start to show here the displacement in the z direction. We can see here, and first thing we have to yes, as we can see, we have to and if and check the geometry. We can see here that the maximum displacement here is almost 5 centimeters, which means that the quality of the problem in Midas GTSNX is the same as Plaxis. If we will revise the Plaxis 3D for the rigid raft foundation, we'll find that we already almost close to this value. And the only difference was that could be related to the thickness of the raft, because there we used it as a plate element, and here we used it as a solid element. So this is the only difference, but we can see that the displacement is almost the same, and even the distribution of the displacement is the same. But here we can see the presentation of the Midas GTSNX is much better than Plaxis 3D, and we have a lot of ways to improve our presentation for the results. Beside here in this panel, we can show in y direction and in x direction, and we can see the total displacement. We here can see the stresses, and even let's see the z displacement. Here we can just throw this bar, we can show the different stages, and we can start to see stresses in z direction. Here we can see auto range, and this is the range of the stresses here and here, as we can see. So another thing we can see here is the plastic point status. As we can see here, it's the same as Plexus, and but Midas is very powerful and creating more complicated geometry, and it's easy to control the boundary condition, and it's easy to perform a sophisticated analysis in a very short time. We can start to show the results of the moment in the shell here. So if we just show the bending moment in x direction, we can see here it's the same as Plexus. So as we can see here, more refinement will be more adequate for the model. And we can see here the maximum and the minimum. Here the maximum moment is 330, which was almost the same result for the other model. And the moment at here is different and from the edges. So here we can see that Midas GTSNX is powerful in its presentation because you can show different ways for smooth or fringe, and you can show it deformed and undeformed, and you can see here you can create even for the contours here you can show the results of the contour as we can see, and you can control it. There is a lot of other stuff here. If we open this model, we can see a lot of material model more than Plexus. So we can see here that it's elastic, Trisca, von Mises, more column, Drager, Prager, Hawk, and a lot of, and beside there is UBC sand or modified UBC sand for liquefaction and for soft soil creep and soft soil and modified more column and many other models. Even we have the accessibility here to model orthotropic material. So the properties is different from different sites. So you can transversely isotropic or joint between rocks, or 2D orthotropic or geogrid. This is another thing is powerful. We can see that here you can go through stages. You have a lot of tools here to create your own model, which make it more adequate for the analysis. Finally, there is a lot of or the last thing we're gonna talk about in this tutorial is there is a lot of ways to define the load and the seismic load, and to have a lot of control. As you can see a lot of techniques about using Midas GTSNX in one of my courses about geotechnical engineering application using Midas GTSNX. In this course, we talk in general about a different application, either in static and dynamic analysis and consolidation and seepage, and even combined analysis between different analyses at the same time. I will stop this video at this point, and next video we are going to improve this model to account for the pile, to compare the results including pile to the other model using Plaxis. Thank you. See you next lecture.